we now show how to negate a universal quantifier. So let's say that you have a finite domain, say S1, S2, and S3. This could be student 1, student 2, and student 3. And let's say that we are considering the predicate h of x to be that student x submitted homework 1. And so suppose that we want to negate the statement for every student x, so for all x, h of x. So first of all, remember that the universal quantifier essentially behaves as a big AND. So this will be equivalent to a big AND over all the domain, which is essentially h of S1 and h of S2 and h of S3. So what we're saying here is that to say that for every x in the domain student 1, student 2, student 3, h of x happened is the same to say that student 1 submitted the homework and student 2 submitted the homework and student 3 submitted the homework, right? So if we want to negate this, we can just take this expression and let's put it here. And we can just essentially negate both sides, right? So we want to know what is the negation of for every x, h of x, and we know that it's equivalent to this huge AND, so we just negate on both sides. But now we can essentially do De Morgan's law, so we know that the negation distributes, so let's do that. So this right-hand side, let me put it here. And so how does this work? So the idea was that the negation enters, but then the ANDs become ORs. So this will just be the negation, so not h of S1 or not h of S2 or not h of S3, right? Which makes a lot of sense if you think about it, to say that it's not true that every student submitted the homework is going to be the same as saying that either student 1 did not submit the homework or student 2 did not submit the homework or student 3 did not submit the homework. But we also saw that this huge, if you do this collection of ORs over the domain, that is just, how do you say, that is just going to be an existential quantifier. So this would just be equivalent to there exists an x such that not h of x, right? So if student 1 didn't do it, or student 2 didn't do the homework, or student 3 didn't do the homework, then it has to be the case that at least one of these is true. So there has to be at least one of them, there exists an x such that they didn't do the homework, right? And so that's how we get our negation. So let me write it here to just conclude for a different color. If you negate for every x h of x, this will be equivalent to there exists an x such that not h of x, so that you negate this. So in other words, or one way to remember this in terms of maybe thinking of it like an algebra rule, is that the negation enters and it swaps a for all to an exists. And this will also be true, and it follows the same idea when we negate an existential quantifier. You will also, if this instead of a for all was a there exists, then this would still go in and the exist would become a for all. So this is how we negate a universal quantifier.